Okay, so in these three examples, we're asked to express the sum of four terms, or more than four terms. In this case, there are four here. In this case, there are six here, and here's four terms. We're asked to express these four terms as a sum using the summation notation. Okay, so we're gonna basically use the Greek letter sigma. So obviously we need a sigma from k is equal to 1 to 4, because we're talking about four terms. And first we're going to explore the numerator. As you can see, the numerator is just increasing by 1, and it starts from 1. So from the k value of 1, you can just safely say that you can put k on the top of your numerator, because if you add using the summation, you will start from k is equal to 1 plus 2 plus 3 plus 4 in the numerator, right? So k coincides with all of these numbers added together from 1 to 4. Now the denominator is a little bit trickier, because if we're thinking of the value of 1 for the k, but there's a 3 instead of the 1. So how do we get to that 3? And then for the k value of 2, we have to have a 5 somehow. So notice that 2 times 1 is equal to 2. 2 times 1 is equal to 2. So my reference number is 2 here, because there's always a difference of 2. 3, 5, 7, 9. Every adjacent number here in the denominators is has a difference of 2. Okay, so 2 times 1 is 2. 2 times 2 is 4. Okay, 2 times 3 is 6, and 2 times 4 is 8. But as you can see, 2 times 1 is not enough, because we need a 3. So 2 plus 1 is 3, 4 plus 1 is 5, 6 plus 1 is 7, and 8 plus 1 is 9. Okay? So basically what we need to add plus 1, plus 1, plus 1 on both sides, and then we're going to get the correct number in the denominator. Okay? So basically what we need, you can copy this down and note that these numbers here, this 1, this 2, this 3, this 4 coincide to the k value. So we're starting from k value is equal to 1, 2, 3, and 4. Alright, so we're talking about that. So we're talking about 2 times the k value, and then we're adding 1 as we decided, right? So it's going to be like this. So this is the correct summation formula that we've derived. Okay, so we've expressed the sum of these four terms using summation, and we have the right input, k, the right function, k divided by 2k plus 1. Now for part B, we have 6 terms, as you can see. So we're gonna start from k is equal to 1 to k is equal to 6. So here, as you can see, the difference is that we're talking about changing signs. We have positive, we have negative, positive, negative, positive, negative. So we definitely need a -1, and a power will be responsible for changing the signs, because if you have an even power, the result will be positive. If you have an odd power, the result will be negative, right? So we have to decide on that. So obviously we're talking about the starting value of 1 for the k. If you put a k here, it will not be enough, because when k is equal to 1, -1 to the first power will give you negative, right? Because this is a odd power, 1. But we need a positive coefficient for the x here, right? To have the positive coefficient, you just do -1. You could do also +1, but -1 would be better. Okay? Because you want to start from basically the 0 power for the -1. So when k is equal to 1, this power will be 0. 1 minus 1 is 0. -1 to the 0 is 1. Okay? When k is equal to 2, this will be -1 to the first power, right? And so for the second term, it will be negative, as it should. Right? So we're done with that. We're done with the changing alternating sign. So now what we have to do, we have to figure out what is going on for these coefficients themselves, aside from the negatives, right? You can see 1, 2, 3, 4, 5, 6. So it looks like it's just the k. That will be sufficient. Just put k. Now also there is x, right? X. And again, the powers seem to also match the numbers, the coefficients, right? 1, power 1, 2, power 2, 3, power 3, 4, right? So it's just to the k. So this is the result. This is the correct answer. Negative 1 to the k minus 1, that will be the function, times the k times x to the k. Now the last example will be from starting 1 to 4, because there are 4 terms, 1, 2, 3, 4. Again, changing signs, so we're going to have a negative 1. We can't put a k because, again, the first coefficient is positive, so we have to do minus 1, like in this case. Now, let's have an x power. We know that the x power rises this time by 2 each time, right? Not by 1 like it was 1, 2, 3, 4, 5. Now it's 1, 3, 5, 7. So we need to think of a rule to do that. So notice that when we're talking, so definitely 2 will be at play because there's a difference of 2 all the time. So 2 will be at play. 2 times 1, right, when the k value is 1, 2 times 1 is 2. But we need 1, right? So we subtract 1. That will give us 1. 2 times 2, when the k value is 2, I can put this in yellow. This is the k value 1. This is k value of 2. 2 times 2 minus 1, that will be 4 minus 1, which is 3. Beautiful. That's what the power is, and that's what the factorial number is. Next, 2 times 3, the k value of 3, accounting for the third term, minus 1, that's going to be 6 minus 1, which is 5. Beautiful. That's the power, that's the factorial number. And now finally, 2 times 4, the k value of 4 is at play, and then minus 1 is equal to 8 minus 1, which is 7. Beautiful. The last power and the last factorial number. Right? So we know that we're talking about a, and what I'm going to do is I'm just going to erase this x and I'm going to write it better. And write it on the top here because we're talking about a fraction. So in the power and the denominator, we're going to put this. So notice that these yellow ones are the k values. And there's always a 2, right? So 2 times k, right? These are the products, respective products with differing k values. 2k and then minus 1, right? So that's the power for the x. And also the denominator, now keep in mind, you got to be careful. The denominator is 2k minus 1, but the whole thing, so just like a power is 2k minus 1, but the whole thing is factorial, right? This number is factorial, 3 factorial, 5 factorial. So 2k minus 1 will represent each of these numbers pertaining to the same factorial, right? So we can't be sure that you include the entire 2k minus 1 under 1 factorial, right? Don't write, let's say, 2k and then minus 1 factorial outside, right? Make sure that you include the whole thing under the factorial, because this whole thing will be considered for the same factorial that you write for it. All right, so this would be the correct answer. So I hope this tutorial was useful and fun. Thanks for watching. See you in the next video.